All right, so for this lesson 352, we're going to be talking about exponential functions and how different ways we compare those. Exponential functions are functions that can be written a times b to the x power. I think some of us still do not really understand exponential functions, so if you don't, make sure you're paying extra close attention to this lesson as we're going to go back over some of those key things. All right. B is the rate of growth or decay. X is the amount of time that's passing normally, usually in intervals of time, not specifically just whatever number it says for time. And f of x is the final output. A is your initial amount. So the growth factor is the multiple by which the quantity increases or decreases over time. The rate of change of an exponential function can be calculated using the slope formula over a specified interval. You can't just calculate it for any random couple of points. You're going to be given some points because it's going to be different. The rate of change is not constant because it's not a linear function. An interval is a continuous series of values. The y-intercept is the point where it crosses the y-axis, so on and so forth. Most of these will not have x-intercept, so we won't be comparing a lot of that. We'll be comparing mostly your intercepts and so on and so forth. Okay, so key concepts, pause, read those. I'm not reading them to you. Identifying the rate of change in y-intercept from context. Determine the interval to be observed. Create a table of values. Choose 2 points, the correct 2 points. X1, Y1, X2, Y2. Plug them in, solve for your slope. The result of the rate of change between the 2 points chosen. Determine which information tells you the y-intercept or the b, which is your initial amount. Determine the interval to be observed if you're giving an equation, right? If you're giving an equation, it's a little bit easier. Pause the video, read all those things. It tells you how to go about solving these problems. Okay. Determine the interval to be observed if you're doing a table. Usually it'll be given to you. Again, average rate of change is pretty straightforward. Look for the point 0, whatever number to find your y-intercept from a table. All right, from a graph, obviously, find where it crosses the y-axis if you're looking for your y-intercept, and pick 2 points, or pick the correct 2 points and find your slope using that slope formula. Okay, pause, read those things, read the misconceptions. Here we go with example 1. So, compare the properties of each of the following 2 functions over the interval, hint, hint, over the interval from 0 to 16. That's important. So, the easy one is right there because they told you what to look for in that table. Okay, so the first thing to point out for function b, so we'll call this g of x just for what we got here. So the y-intercept, also known as g of 0, is 850. In other words, it's 0, 850. All right. Now, let's take a look at function a. So we'll call this f of x. So for f of x, let's see if we can find our y-intercept. Since it's a graph, I just need to go back and look where it crosses. Okay. Now, that's 800. That's 900. This looks about halfway in between. So we're going to go out on a limb here and say that that's 0, 850 as well. So when I compare these two, I would simply say that they have the same starting point. They have the same y-intercept. Okay, both the graph and the table. Now, to calculate the rate of change, we need to know the points. So let's see here, 16. We're at 1600. So that one's going to be super nice for y-intercept. So that point there is again 1600. We're going to use our y-intercept, which is 0, 850. Okay, so my rate of change, okay, my average rate of change, which I should have called it. It's not slow. Average rate of change, ROC, right, is going to be my slope formula for this curve, right? It's the average rate of change between those 2 points. It's the straight line that cuts those 2 points. Okay, it's the slope of that. Okay, so here we go. That would be 1600 minus 850 over 16 minus 0. Okay, so that would be 1600 minus 850, which is 750 divided by 16. And 750 divided by 16 is 46.875. Okay, now we need to compare that with the other one. Now, I can already tell you, since the top one's the same, and this bottom one is actually the 16, and this, since that's lower than 16, it should be a smaller number for my slope. So let's find out. So 1480 minus 850, remember y2 minus y1, and x2, x1, over 16 minus 0, going to be 630 divided by 16, and 630. I did rounded this. It should be 0.88. It should be 630.88. That's going to equal 39.43. So how do we compare those? What does that tell us? The average rate of change, right? Even though their initial values are the same, the average rate of change for f of x is greater than the average rate of change for g of x, which means that function a, the f of x function, is increasing at a faster rate. Okay? All right, we're going to move on. All right, take a look at this next one. Petri dish contains 8 bacteria that doubles every 15 minutes. Compare the property of the function that represents the situation to another population of bacteria growth that's given by the graph. It starts with 8 organisms. So both of them start with 8. Cool. All right, so a Petri dish contains 8 bacteria that doubles every 15 minutes. First off, what are we measuring by down here? Oh, minutes. Good. So I want to measure by minutes on my equation that I'm going to create here too. So for g of x, I want to start with my initial amount, which is 8. And then what's it doing? Oh, hint. It's doubling. That's going to be the base. This is the part that a lot of you are messing up. And then it doubles every 15 minutes. So the interval over which it doubles is 15 minutes, and x is the number of minutes. So in 15 minutes, it would double once. In 30 minutes, it would double twice, and so on and so forth. Okay? So now that I have an equation and I have a table, a graph, I can figure it out, my rate of change over that interval, and I can also look for my y-intercept. Okay? My y-intercept on the graph is very simple. I simply have to do what? Find it here. Okay? Oh, wait. They already told me, didn't they? It's 8. And it was 8 for the other one too, wasn't it? Super easy. Don't forget to read your problem. So g of x, right, or g of 0 is going to be 0, 8. And then for the next one for the graph, we'll call this f of x. Okay, f of 0 is also 8. So 0, 8. We'll start it that way. Now, we're supposed to know our rate of change. Okay? Rate of change between 150 and 210. So at 150, we're going to have to kind of figure out where we are there. And then at 210, it looks like we're at 1,000. So that part's easy. Now, best guess here is we're at about 250. Okay, so we go up 200, and then so 300 would be the halfway mark, and we're a little over half of that. So 250. All right, so for f of that, we're going to do rate of change between the following 2 points, between 150, 250, and 210, 1,000. All right, and so when I do that, that would be 1,000 minus 250 over 210 minus 150. Or, in other words,